Okay, we'll do an example which illustrates the central limit theorem. The IQ(x) of an individual is approximately instead of saying, let's say humans, is approximately normally distributed with mean mu equals 100 and standard deviation sigma equals 15. Okay, so let's start off with A. If a person is selected at random, what is the probability that the person's IQ is greater or equal to 115? Okay, so what we're going to so we compute the probability of x being greater or equal to 115. So what we're going to do is we're going to use the TI-83 calculator, and we're going to do second distribution to normal CDF, and we're going to put normal CDF, and see, I'll draw the picture here, but I'm sort of going too fast maybe. But here's the mean is 110, and we're looking at 115, and I'm trying to find that area right there. So I put the left endpoint 115, and the right endpoint should be a large number. And I'll just pick the biggest number I can put in the calculator. I'll put E99, and then I'll put the mean, which is 100, and the, I wanted to do greater or equal to 110. That's staying with my notes. Sorry, let me just do 110. So what's the probability it's greater or equal to 110? So then I'm going to put 110. I'm sorry, I'm going to put 100 here, and then the standard deviation is 15. Okay, so I'm going to put 110 here also. Actually, I'm just getting these all mixed up. Okay, here's 100. Here's 110. Okay, and so I'm going to put that in the calculator, and I mean 110 is not even a full standard deviation above 100 above the mean, so it's 10 above, and the standard deviation is 15, so that's 10 out of 15, so that's 2/3. So that sort of tells us something about what we should expect for our number. So I'm getting that this is equal to 2.5249, etc., which is approximately 25%. Okay. So this is, I don't really like talking about IQ all the time because I think it's sort of nonsense, but they have these tests, and supposedly you can see how smart someone is. But you could talk about male height or female height and then say, what's the probability that a randomly selected person is greater than a certain height? So this is just a normally distributed population. The mean is 100. The standard deviation is 15. So if I choose someone at random from the population, what's the probability it's greater than 110? We use the TI-83, plug it in there, get that answer. Now, part B is, suppose we take a random sample of n equals 16 people is taken. Now here n is not greater than or equal to 30, but our underlying population is a normal distribution, so 16 should be fine. To assume that our sample mean will be normally distributed also. Okay, what is the probability that the sample mean x bar is greater than or equal to 110? Okay, so that is find the probability that x bar is greater or equal to 110. So now x bar has the same mean as the population. Mu x bar is equal to mu, which is equal to 100. And the standard error, sigma x bar, is equal to the standard deviation of the population divided by the square root of n. That's important for us to look at. So this is going to be for the population, standard deviation is 15, and then we take square root of n, which is 16. So that's 15 over 4. And you can do that on a calculator, but that's 3.75. The thing is, don't round that number. This turns out to be exactly 3.75, but don't round it off. When you're doing your calculations, it's way better to put in this into our calculation on the calculator. And so here we have 110, and we're trying to find this area here. So for the TI-84, we're going to do second, same stuff as always that we see, second distribution to normal CDF. And so then we're going to write normal CDF, and I'm supposed to, I have the picture up here. Okay, so this is going to be 110 E99, because this is our left endpoint. The right endpoint is infinity, so I put the largest number I can because there's no infinity on the calculator. I'm going to put in mu x bar, which is 100. This is the key, is that you put in sigma x bar, which is 15 divided by the square root of 16, and that's 3.75. Don't round a number when you put it in there. That's going to ruin everything. So if you had to put 15 divided by the square root of 16 in there, do that. Okay. So this turns out to be a much smaller number than what we had before. If I did it right. It seems really small. So the point is, if you take a random sample, did I say random sample? Random sample of 16 people, you're going to get something way closer to the average of that sample. It's not to say there's not some people that are above average or below average, but on average, you're starting to get something really close to 100, because it's very unlikely. What is this saying? It's very unlikely that you sample 10 people. No, what was it? 16 people. It's very unlikely that you sample 16 people and the whole sample has an IQ higher than 110 on average. If you do a random sample, on average, you're going to get close to the sample of the population, which is a good thing, because that's why we're sampling. We're sampling to see what the whole population is, and this is saying, look, oh no, if you actually take a sample of 16 randomly, you shouldn't get something way off from the population. You shouldn't get 110 and above. The reason we're going to do all this sampling is because we want to see what's going on with the population. I mean, if you went over to, Harvard and randomly selected people, that's not a random sample. I mean, you took a sample from Harvard, and I think we would get people with higher IQs, but that's not what we're talking about. We're talking about the whole population. And besides, these tests are sort of nonsense because people have different types of intelligence. So someone who's brilliant at physics, for example, if they were put in a country or a place where they had to be a hunter-gatherer, they might not do well. Maybe they do well, but there's different skills there, different intelligence being used. All right.